Okay guys, so we're going to pick up where we left off on Friday. First thing we want to do is take a look at our equation. I want to subtract 7 from both sides, so I'll get that y minus 7 equals 2x squared plus 8x. Next thing I want to do is I want to factor out the 2 so I can get x squared by itself. And I'm going to get rid of that because I need to add something here. And remember, it's always that b value divided by 2 squared. So 4 divided by 2 is 2 squared is 4, so we're adding 4 right there. And then what we need to realize is we're actually adding 8 because 2 times 4 is 8. So I have to add 8 to the other side. And then you can say, okay, x squared plus 4x plus 4, that is really x plus 2 squared. And then move the 1 to the other side, makes it negative 1. So I know that my vertex is going to be at negative 2, negative 1. And then, if you need to, make a wide table of values, but you have to realize that this 2 out here multiplies it, vertically stretches it. So while it would originally look like this, go to the left 1, up 1, go to the left 2, up 4, it's actually multiplying how far up it goes by 2. So instead of going over 1, up 1, it's really going over 1, up 2, and then over 2, up 8 it should. And I don't know why that keeps on popping up, but 2 up 8 should make it right about there. Do the same thing on the other side. And that is driving me insane. And then something I kept on forgetting about is the axis of the parabola. Well, that would be the vertical line of the axis of symmetry. It goes right through the middle, okay? And basically, since this is a vertical line, it's going to be x equals, and then the x value of that vertex would be negative 2. So x equals negative 2 is our axis of symmetry. Okay. So first thing I want to do with this equation right here is I want to get rid of that negative 6. So right away I'm going to rewrite this as y plus 6 equals negative 1/3 x squared plus 3x. Next thing I want to do is I want to get the x squared by itself. So I'm going to factor out negative 1/3 from both terms. This is where it gets kind of weird, because when you take 3 and you divide it by negative 1/3, you get negative 9. Dividing by negative 1/3 is the same thing as multiplying by negative 3. And then I have to figure out, okay, what is this number that I'm adding to both sides? Well, you have to take your b value, negative 9, divided by 2, and you square it. And that is going to be 20.25. Now, if I add 20.25 in here, I'm actually adding negative 1/3 of that. If you multiply these two, then you're actually going to get negative 6.75. So to the other side, I have to add negative 6.75. And then remember, it's always going to be x and then half of this number. So negative 4.5 squared. And then I have to add the 0.75 to the other side. And my vertex is going to be at 4, 0.75, right there. And then my multiplier is negative 1/3. So usually before I would go right one, up one. So now it's actually going right one, down 1/3. Same thing with the left side. And then instead of going right 2, down 4, it's actually going right 2, down, and then 1/3 of 4 is 1.333. If you need to, plug in values. That's totally fine. And then the axis of symmetry, vertical line going right through the center. The y value, excuse me, the x value of the vertex is 4, so it's going to be x equals 4 is your vertex. Now there's two ways to find your x-intercepts, and that is by factoring or using the quadratic formula. And I'm going to show you a version of both. Okay. All right, here, first of all, I want to find the x-intercepts. Oh, God. X-intercepts. So the first thing I'm going to do is I'm going to factor it. And I'm going to factor out the negative first. So y equals, and then negative, that would be x squared minus 6x plus 8. And then I want to factor this out. And it's going to turn into x minus 4 times x minus 2. And then if you set each of these equal to 0, you can have x equals 4 and x equals 2. Those are my two x-intercepts. So I'll put some dots there. And then I need to do my completing the square. So I'm going to move the 8 over right away from this equation and move this 8 to the other side to make it y plus 8 equals negative x squared minus 6x plus 6x, excuse me. And then I want to factor out that negative. You always get the x squared by itself. And that plus 6x becomes negative 6x. And then you're asking, what do I have to add? And then, so negative 6 divided by 2 squared is 9. So I'm adding 9, but really that's negative 9. So since I'm subtracting 9 to one side, I have to subtract 9 to the other. And this turns into y minus 1 equals negative. And then this right here would be the same thing as x minus 3 squared. Move the 1 to the other side, make it positive. And I know my vertex is going to be at 3, 1. Just like that. And because my multiplier out here is really a negative 1, I'm going to go right 1, down 1. Hey, it works out. And then right 1, down 4. And I apologize about that box that keeps on popping up, driving me nuts too. Just checking my notes, gotta make sure that I did everything. Okay. Next one. Okay, let's do completing the square first because exercise, this is not going to be a nice one to factor. So we're going to have to use quadratic formula. So first thing I'm going to do is move that negative 41 to the other side, make it positive 41. Then I'm going to factor out the negative 4. Then I have to figure out what I'm adding there. Make sure that's 41. Say half of 6, and negative 6 is negative 3. Square that, it's 9, so I'm adding 9. But that's really negative 4 times 9, so that's negative 36. Half of negative 6 is negative 3. So I know my vertex is going to be at 3, negative 5. And just looking at this, I see my multiplier out here is negative 4. That means instead of going right 1, up 1, it's really going to go right 1, down 4. So it'd be right here. And same thing with this other side, down 4. So this is negative. I know it's going to open down. And I'm not going to have any x-intercepts. No x-intercepts. So I could run the quadratic formula, and you know what, I'm going to do it just to remind you guys. If you need to, skip over this part. That's totally fine. Insert a new slide. And I'm going to show you how to run the quadratic formula for this. So I've got y equals negative 4 x squared plus 24 x minus 41. x equals, your x-intercept is equal to negative b, so your b value is 24, in the form ax squared plus bx plus c. Your b value is 24 plus or minus the square root of b squared, so 24 squared minus 4ac, so negative 4 times negative 41, all over 2a, so negative 4. Now we're going to simplify. We got negative 24 out in front, plus or minus big square root. On the bottom, 2 times negative 4 is negative 8. On the inside, I'm going to say 24 I need to square that, and then I need to subtract 4, multiply that by negative 4, and then multiply that by negative 41. That gives me negative 80 simplified. Now, can you take the square root of negative 80? No. So that means whenever you get a negative number down here in the underneath the radical, that is when you're going to have no solution. And just like we expected, back here we have no solution for the x-intercepts. Alright, so we're going to keep on going and then finding the minimum and the maximum values. The minimum occurs at x equals negative b over 2a, and same thing with the maximum. It just depends on whether your a value tells you to open it up, if it's positive, or if your a value is negative, it tells you that it opens down. That's it. So that's actually the quicker way of finding the vertex. And instead of doing all that work to do the completing the square, which is totally fine, you could also do, if you, let's say, I'll take an example that we've done before. Let's say that the equation this is pissing me off. 2x squared plus 6x minus 3 and we completed the square for that. But if you wanted to know what the x value of the vertex would be, all you would have to do is take negative b over 2a, which is negative 6 over 2 times 2, which is negative 6 over 4, negative 3 halves. And then that's the x value of the vertex. And then the y value you would find by plugging it in. If you don't get this, that's fine. Just continue to complete the square. Plug that in, see what you get. And you would still get negative 7.5, which is exactly what we got when we complete the square. We got the vertex would be at negative 3 halves, or negative 1.5, comma, negative 7.5. So we are given the path of a baseball. It's given by this function. And what that would look like, if I do a little drawing, is that when the baseball is hit, it's going to go up, and then it's going to come down. It's a real slight parabola. And then because a is less than 0, the function has a maximum. So let me redraw this real quick. The vertex right here, that would be a maximum. And x equals negative b over 2a. Well, okay, let's figure out what that x value would be. Let's plug in our negative b over 2a. So our b value would be 1 right there, over 2 times our a value. So negative 0.0032. Let's plug that into the calculator, see what we get. And when we plug it in, we get 156.25. And that would be in feet. So that means that when we're looking at this, we say, all right, if it starts here at 0, it goes 156.25 feet to get to where it gets its highest point, and then it's going to drop from there. So to figure out what the maximum height would be, all you do is plug in this value into the function. So we're going to do f of 156.25 plus since that is the x value of a vertex, basically our maximum, plug in that into our function, and that will help us find the y value. And the y value tells us the maximum height would be 81.125 feet. And I found that by plugging in 156. That is it. You have the rest of the time to do your homework.